Okay, so slope and rate of change. Now we're going to get into, now that we have a feel for and are more comfortable with horizontal and vertical lines, the slope of horizontal and vertical lines, we're going to get into the um, graphs, like things other than horizontal and vertical lines. We're going to get into your diagonal lines. So this is going to be page 32 in your binder. Okay. Anyway, it says Jerry has two hills near his house that he can choose from to go sledding. A side view of each hill is given below. Compare the vertical distance or the rise, and then compare the horizontal distance or the run of each hill. Okay, so we're comparing the vertical distance, the rise. We're talking about 20 yards, rising 20 yards versus rising 10 yards. Okay, and my pen is deciding to not allow me to do any kind of writing. That's always fun. Always a fun way to start a video. Nice. Okay, give me a second. Okay, I think the video stopped lagging. Anyway, so the rise, we're comparing 20 yards here in hill A and 10 yards here in hill B. Okay, so what do we notice about it? Well, it seems like you have to go higher on hill A than you do hill B. So hill A rises higher. Let me zoom out, and I guess it didn't. Oh, nice. Maybe it's because I'm recording. I don't know. Don't know what's going on. Here we go. This is just all going downhill right now. Okay, guess we got it together. Now compare the horizontal distance or the run of each hill. Well, if we look at the run for both hills, it seems like we are going to be running the same distance. We're going to be running 20 yards on both hills. Okay, which hill is steeper? Explain your reasoning. When we're talking about steepness, we're talking about how upright the hill is, right? Um, Steepness. Think about whenever those of you that are in athletics, think about whenever you are the one that is running up the hill. The one that is steeper is going to be the one that's more vertical and it's harder to run up on. Okay. Less steep would be, so here, comparing these two, we're talking about hill A would be steeper because it rises higher in the same distance. You're going the same distance both times, but it is higher than hill B. So, slope. On graphs of linear relationships, slope describes the steepness of a line. And you also want to think about it as the speed or the velocity of that line. It describes the steepness. Okay. Slope. We talked about it in the last lesson. M. M is the variable that we use for slope, is also the ratio of the vertical change compared to the horizontal change, or the rise over the run. Slope is equal to the rate of change of the graph. So up here where it says slope and rate of change, they actually mean the same thing. So if on a test question you ever get asked what is the rate of change, they're also asking for slope. And while we're on that, different words for slope. Words that they can use in the place of slope, because, STAAR test, not always as easy as what is the slope of the line, right? They can ask what is the steepness, and not the stepness, steepness. Thank you for that. Steep. My videos aren't cooperating today. Rate, ratio is another word. And you've seen these words: per, each, and every are basically the same word. Every. And then the most popular one that they'll ask is, what is the rate of change? How fast is my line changing? Okay, speed, velocity. Now you might want to pause the video to write the rest of those down, but I'm moving on here. Okay, now when we're thinking about slope, let's just look at our graph. We have an X and we have a Y-axis, correct? Well, the vertical change that we're talking about right here is how fast it goes up and down. So if you're looking at your X and your Y-axis, the Y-axis is the one that goes up and down. So this would be considered your vertical change, delta Y. Now, I know you guys see that triangle. You're like, what is that triangle? That is the symbol for delta, and delta is a word that means change. So just in case you forget, change, okay? And then it's compared to the horizontal change. Well, the x-axis is the one that goes horizontally. So this would be our horizontal change right here. Delta x. All right. So to find the slope of the line, M, you would find the change in y. How much does it change? Does it go from 0 to 1? Does it go from 0 to 2, 0 to 3, 0 to 4, etc.? And how much does it change horizontally? How much does it rise? How much does it run? Okay. Now, even though we use rise over run a lot for slope, we use it to describe slope a whole lot. Just keep in mind that is not a way, they don't use these words on the STAAR test. They want to ask you, what is the rise over run of this line? Okay. All right, so thinking back into the previous lesson with horizontal and vertical lines, you guys watched a video over slope dude. Okay, so we're going to go back over the 4 different types of slopes that we see by labeling each graph here at the right. Okay. One thing that you want to keep in mind is that anytime you read a graph, anytime you read a line, you want to read. Ooh, that might be a little too light. Thought I was doing something good here. All right, you want to read graphs from left to right, just like you would read a book. Okay. So if we look at this line right here that's graphed, we start here at the bottom or at the left on the left side of it. You got your negative numbers here, positive numbers here. Okay. And we would go up to the right, up and to the right. Since we are going, since we are going up means our slope is going to be positive. Okay. Here, we would start on the left side. To get from one point to the next, we would have to go what direction? Down. Down means negative, down into the right. So since we are going down, this is a negative slope. Okay. Here, to go from one to the next, I don't go up, I don't go down. So if I'm just going straight across, that would be 0. Okay. Now this is a horizontal line. We talked about horizontal lines yesterday. If you're doing calculations, remember this is where you can have a 0 in the numerator. 0 divided by anything is 0. So the slope of this line is 0. Another way to remember that horizontal lines have a 0 slope is that you can actually form the letter Z with a horizontal line. Z for 0, right? And the last one over here at the end, we have a vertical line. Thinking back to yesterday's lesson, what is the slope of a vertical line? We know that it is undefined. Undefined. Okay. With this slope, you can actually, in a weird way, turn it into a U for undefined. If we are calculating mathematically the slope of a line, which we will do here with this unit, that's where you see the 0 in the bottom, which 0 in the bottom, not possible. It's undefined, okay? Can't divide by 0. I don't know why I put canned. Maybe I got candy on my mind. Can't divide by 0, okay? So it says, no, here for numbers 1 through 3, find the slope of each graph by comparing the ratio of rise over run. Okay, well, rise is the amount of boxes that you go up. Run is the amount of boxes that you go across. Now, boxes do not have to be a whole box in order for it to count. It can be, you can have part of a box, okay? Because notice here, this line is slicing through this whole box, but it still counts as a box, okay? And you want to count the boxes, don't count the lines, count the boxes. One other thing to keep in mind whenever you're trying to find the slope, always draw a right triangle above the line, not below, okay? Let's write that in. So if it was a positive slope, your triangle would be there. If it's a negative slope, your triangle would look like that, but always above the line. Did I do it above the line? I did not over here. That is my fault right there. Okay. I'll show you how to do it for a negative again. That is my fault, 100%. But since I already found the mistake here, I'm gonna go ahead and address it. When we're finding the slope, the word rise always comes first. So you have to rise first, run toward the positive number. So that makes this line positive. You rise, but this time you're running backwards. Since you're running backwards, you're running toward the negative number. So that's what makes this one negative, and it's also going down. Okay. 100% my fault. I'm so sorry about that one. Okay, so let's look at it. First, you want to draw your right triangle above the line. And the very first step you want to take is to rise. Okay, it doesn't matter if you're rising from the left side or the right side. So we're going to go ahead and ignore this right here. Read rise from left to right. I used to teach it that way. I'm having a lot of brain farts here. Sorry. Anyway, so how many do we go up? We rise by 1, 2 boxes. So the top number in my fraction is going to be 2. And now we're running to the right, 1, 2, 3 boxes. Since we're running to the right, that makes my slope positive. Now, one thing about slope is that 9 out of 10 times you're going to end up with a fraction. And so with all fractions, we want to simplify. I left my calculator ready to go, and here we go. So to type your fraction in and just press enter, the calculator will do the simplifying for you. If it changes, write the new fraction. If it doesn't change, then that just means it is simplified. It is in its simplest form. So the slope of this line is 2/3. Let's try another one. Okay, now with this one, notice we don't have any points picked out for us. So you want to pick a good point. A good point is going to be where you see, you'll find it at the perfect intersection of the grid and the line. Okay, so with this one, you see that it's crossing perfectly there. This one would not be a good point just because it's in the middle of the 2 boxes. You want it to be somewhere where it's going to cross perfectly. Okay, so we're actually going to get rid of this right here. Get rid of that. This one is just off by a very little bit, but here we go. This is a good point, and this one's a good point. Now, one thing you also will need to keep in mind, or you need to pay attention to, is if you look at your y-axis, what happens? Our units are counting by 2s, so you want to be careful with units. Be careful with those units, all right? Let's draw a right triangle. Right triangle always, always, always goes above the line, not below the line, okay? We're going to find the rise over run. Come on. Zoom out faster. There we go. Awesome. Okay. So how many boxes do we go up? We go up 1, 2. So that would be our top number. Actually, we didn't go up 2. I'm already catching myself making all kinds of mistakes. Since each box counts for 2, it's actually 2, 4. Okay, going backwards, since we are going backwards, that makes the number negative. Okay, but going backward, or the x-axis is also counting by 2s. So 2, 4, 6, 8, making that a -8. 4 over -8, let's check our fraction. Come on, 4 over -8. That gives us -1/2. Okay. And this last one here should be hopefully a little easier. You have a vertical line. Vertical lines can be turned into the letter U. And what does the U stand for? Undefined. So the slope is undefined. Okay. It is a vertical line. You can also use the acronym VUX to help you out. The U in VUX stands for undefined. All right, turn the page. All right, so backside. It says use your knowledge of slope and rate of change to answer each question. Clark loads boxes of paper on a pallet before shipping them. The graph shows the linear relationship between the number of boxes of copy paper and the weight of the pallet. Find the rate of change. That's how it's going to be asked on a STAR test. They'll just simply ask you find the rate of change. They're not going to ask you find the slope of the pallet with the weight of the pallet weight with respect to the number of boxes. Okay. Well, we know that finding the rate of change means to find the slope. So to find the slope of a graph, we use rise over run. Okay. Now, one thing we need to keep in mind is to check our units. Our x-axis goes by ones, but our y-axis is jumping by tens. Okay. Let's draw our right triangle. You want to draw it right above the line, not below. And we count how many we go up, 10, 20. So we go up by 20. We rise 20. And then we go to the right, meaning it's going to be positive. 1, 2, 3, 4. All right, now 20 divided by 4 gives us 5. Okay, now our rise, because we do need to include some types of units, we have pounds and number of boxes. Our rise describes the weight in pounds, so that means it's 5 pounds. LBS is an abbreviation for pounds. Our run describes the number of boxes, so 5 pounds per box. Okay. Number 5. Lainey set up a lemonade stand. The graph below shows the amount of money in her cash register with respect to the number of customers she has served. Find the, there it is, rate of change. I'll change colors. Oh gosh. All right. Find the rate of change. To find the rate of change, we use rise over run because we have a graph. Once we do not have a graph available, we'll be using a different method. All right. Our x-axis is going by ones, our y-axis also going by one, so I don't have to be careful there, but we do need to find 2 good points. Now, one of the points that or a couple of the points that I always look to use would be my x-intercept and my y-intercept. Where does it land on the y-axis? Where does it land on the x-axis? And in this case, it is a good, does give us a good starting point here on the y-axis. So I'm going to go ahead and use this point. And the other point I would use is probably 4, 6. So draw your right triangle above the line, not below. Count how many boxes you go up. 2, 3. So we go up by 3, positive 3. And we go to the right, 1, 2, 3, 4. Since we're going right, that's a positive 4. Okay. You type in 3/4 in to the calculator and it's not going to simplify. It is in its simplest form. So that means the rise describes dollars, $3 per. Remember, per is that word that we use to describe slope. Per, my run describes customers. So $3 per 4 customers. Okay, that's how it would be written in words. $3 per 4 customers. Okay. The reason we left this one by it this way is because it's a whole number. If we're given a whole number, that's just over 1. So that's 5 pounds per 1 box. Okay, just in case you were confused by that answer. Number 6, a cold front hit Milwaukee, Wisconsin, and the graph shows the outside temperature with respect to the time past in hours. Find the keyword, find the rate of change. Okay, so let's find two good points that we can use. We are provided a graph, so we use the rise over run method. Here's our x-axis is going by ones. Look at your y-axis. Notice it is not going by ones, it's going by fives. Okay, counting by fives. I think this is a good point here, and probably this one right here. Draw your right triangle above. We're going to go up by 5, 10, because we're counting by fives. And this time we're running backwards. Since we are running backwards, that's going to make our number what? Negative. 1, 2, 3. Okay. We put this into our calculator. 10 over negative 3 stays the same. So what the negative is going to do is it's going to tell us that we are what? We are decreasing our temperature. Okay. Okay. So that would mean that we are decreasing 10 degrees Fahrenheit per 3 hours. Oops. We already have the number 3 there. Per 3 hours. Man, this is really not cooperating. All right, number 7. Jacob hopes to read at least 4 pages every 5 minutes of his sci-fi book. The graph shows the rate at which he reads. Did Jacob meet his goals? Okay, well, let's find the slope of the line using rise over run method because we are provided a graph. If we're not provided a graph, there's going to be a different method there. Let's check our axis. Our x-axis is going by what? By threes. We check our y-axis also going by threes. Okay, so we need to be careful. We can use our y-intercept, x-intercept, whatever. 15.9 sounds like a good point to use. I'm going to go up. So we're going to go up by 1, 3, 6, 9. And we're going to go to the right, making that also a positive. 3, 6, 9, 12, 15. So that would give us 9 over 15. Now, does 9 over 15 simplify? Does it reduce? It should. Let's try it. Gives us 3 over 5. And that's not a z, that's an equal sign. Ooh. We're going to start doing that, huh? Equals 3 over 5. So what does that mean? That he reads 3 pages per 5 minutes. So does he meet his goal? The goal was to read 4 pages every 5 minutes. He's only reading 3 pages per 5 minutes, so he did not meet his goal. He did not meet his goal. Number 8, last one. It says 3 lines are graphed below. Use the information in the table to help you fill in the missing rate of change and record the letter of each line that matches the situation. Okay. Well, you notice first thing I would look at is the fact that you have 2 lines that are going up. So 2 lines are going to have a what? Positive slope. And the other line's going to have a negative slope because this one's going down. Well, two of the situations talk about saving money, but the last one talks about spending money. So which one do you think that one's going to be? That one's going to be line A, spending. And since we are spending, we are subtracting, right? We're decreasing $7 every week. Every how many weeks? Meaning 1 week. So that is negative 7/1. All right, now saving money. We're saving $11 every 3 weeks. Saving, positive, positive, right? 11 every 3 weeks. We're saving 9 every 2 weeks. Okay, well, maybe if we were to put these into decimal form, it would give us a better perspective of what kind of number that gives us. So negative 11 over 3 gives us negative 3.667, right? Just did some rounding there. Oh, it's positive. I don't know why I typed it in as a negative. And then we have 9 over 2. 9 over 2 is 4.5. So those decimal numbers should help us come up with which one line B and line C is. Well, line C is less steep. It's lower, meaning that lower number is going to go to that line. Line B is steeper, higher, so it's going to be changing at a faster rate, which is line B. Okay, and now it's time for you guys to practice on your own.